Good morning, everybody. So yeah, I'm Tom Rondeau. I am known as the Principal Director of Future Generation Wireless Technologies, or Future G as we call it in the DoD. So I work for the Undersecretary of Defense for Research and Engineering, and this is one of her defined 14 critical technology areas. So looking across all high-tech areas and trying to understand how they benefit the warfighter, how they benefit the Department of Defense, and understanding future generation wireless technologies is critical to the success of the U.S. Department of Defense for our warfighting, our peacekeeping, and our humanitarian capabilities. So that's what I'm here for, is to talk about how the U.S. envisions using this technology, advancing it, adopting it, and innovating within this space to make sure that we are taking as much advantage of the commercial industry as possible. The needs of the military, as far as data, communications, and decision-making capabilities in the field, all rely on high-speed information, trusting that information, managing it and controlling it. So, looking at the past couple decades of innovation in the commercial sector, we see the rapid advancements of cellular technologies, wireless capabilities in the field, and 5G was a game changer for many reasons. It started to break apart what the network meant as far as just downloading information from the cell towers to you as a user, to starting to think about the connectivity of machines, the connectivity of things. And we look at that from the DoD's perspective and say, hey, we could actually use that because all of our needs are niche, all of our problems are unique, and traditionally we've wanted to build special purpose hardware, data links, and radio systems to fit those. Well, now if we can actually utilize the innovation cycle, the scale, the affordability of commercial technology for those purposes, that's a major benefit for us. But we also need to, as I said, trust and be able to manage that information at all times. So we have an extra burden of security that we need to layer on top of these things. So it's not just pulling 5G technologies into our capabilities, but it's also making sure that we're advancing them and thinking hard about not only the security of these systems, but what comes next and continuing to embed that within these systems. So we've been focused on 5G for the past few years. I am the future G, so I get to think about 6G, maybe 7G. Whenever the G's stop, we get to play a part in that conversation. So what I've done is thinking about how these technologies are applied to our DoD operational perspectives. So we've crafted out these really 5 lines of effort in order to best take advantage of this technology and make sure that it is applicable in different areas of concern for the DoD. So we start on the side here of resilient, open commercial solutions. This is how do we make sure that we're engaging with the commercial industry, and how do we make sure that we're best positioned to take advantage of it, but also, frankly, provide some leadership, because we need to make sure that what industry is pushing towards, what 6G even looks like, is most beneficial to our needs and frankly our values as a country. So making sure that we have access to this technology, working dual use concepts of this, is kind of the base of a lot of efforts in the office. We're also looking at what we call ubiquitous, secure, and instant access. Now this is really the vision that we've all in the networking world had for many decades. No matter where we are in the world, how do we make sure that we have instant and secure access to the information plane? So putting all this together creates so in the most austere environments, the middle of the Pacific Ocean, wherever we are, we want to make sure that we have that access, thinking about those technologies that are going to matter for that line of effort. Then if you go farther into what the U.S. military does, engage in warfighting, peacekeeping, and humanitarian activities, now we're up facing real threats, kinetic, electronic, cyber threats. So we need to make sure that in this expeditionary and tactical case, we are also increasing our ability to use these technologies and understand the risks and the posture that we have to have if we're going to use them in the field. So studying that pretty hard. Next, we go into one of the more research areas, integrated sensing and communications. This is a really exciting and blossoming area of research and development for 6G. how do we actually use these signals of opportunity as a sensing modality as well? Now that provides a lot of opportunities for us in the DoD. Sensing and intelligence sensing and reconnaissance is one of our major operational tasks. How do we use this for our purposes? But it also acts as a threat to our operational stance. So we need to make sure that we're understanding it and can protect ourselves from an adversarial use of that technology. Privacy becomes a big component of IS&C. And then finally, thinking about putting a lot of these issues together, we've crafted out one area of effort called smart, resilient logistics. Logistics is a huge problem for the DoD. If you were here yesterday, you heard Walmart talking about similar issues that they have. So again, this back to that dual use of these commercial technologies. How do we improve our ability to move supplies, maintenance parts, food, and weapons wherever we need them in the world when we need them? So this technology is a game changer for that. So those are the areas that we've crafted out and looking to apply 5G, 6G, future G technologies in each one of them. So another way to look at that is in this space here. So you can look at what we're doing in these different LOEs, but I want to focus on how they do come together in the middle for very specific technology attributes that we're going to take advantage of and continue to invest in and push research in. That's these cross-cutting capabilities. Everything we're talking about, we need to understand the security of it. We're trying to open up access to these technologies as much as possible, which is why we're here with the Linux Foundation. And we're trying to make sure that they're more secure through open and transparency within the technology here. We also recognize that we have a workforce development opportunity, I'm going to call it. Right? Within our commercial world, we need to make sure that we're developing the best talents, that we have the skilled workforce to be able to take advantage of this high-tech 5G, 6G capabilities for these new markets that can emerge from it. I need to have a smart and educated workforce within the Department of Defense so that we can figure out how to apply that most appropriately to our mission sets. So for all that, we've crafted a handful of priority efforts for this year. So I'm going to start with what we call the DoD RAN sharing, right? The radio access network. The point of this one is trillions of dollars have gone into building what we call the global information infrastructure. Almost anywhere you go in many countries, US, Korea, Japan, you'll find access to a 5G or at least a 4G, but even now increasingly 5G infrastructure. How can we best make use of that? We have to think about, again, the security risks of using foreign-owned, foreign-made infrastructure, but also making sure that we understand the deals that we can make with these countries, with our partners and allies, in order to most effectively utilize their infrastructure. So that's a big effort to make sure that we have that ubiquitous, secure, and instant access wherever we are. In our expeditionary tactical use, we've crafted a project working with our NATO allies. How do we make sure that we are engaging with NATO standards, NATO mission needs, so partner force operations, and how do you bring your tactical radio to the field and be able to utilize it and communicate effectively with our partner forces. The current 5G and future G technologies are a way to actually enable that through innovative uses of the standard, but also maintaining standards compliancy. Under integrated sensing and communications, as I said, this is a really interesting research project. And so understanding how the spectrum works, understanding new spectrum bands, if you're following the spectrum, our spectrum debates, there's this new frequency range 3, FR3, that's being defined, 7 to 24 gigahertz. As that opens up, as we understand how to utilize the propagation and the modalities of RF from a sensing perspective of that band, but as well as the millimeter wave band and the low bands, we have the opportunity to understand the complexity of sensing in real-world environments. So we've been setting up ranges for spectrum operations and for being able to study what this looks like. We've kicked off some workforce development projects. In fact, I was out at the Naval Postgrad School just south of us earlier this week, working with them to start training up our Navy postgrads to build up that internal workforce and education within the DoD. And we have this Microelectronics Commons. This is the DoD's application of the CHIPS funds. We have $2 billion. We've applied them to create these regional hubs. We have 8 of them around the country. 4 of them have a part of their efforts dedicated to 5G and 6G microelectronics research and efforts. So we're engaged with that to enhance our semiconductor path. And finally, we go back to the ROCs, the resilience and open commercial solutions. One of the big areas that you're going to hear today, if you come and join us for our 6G Innovation Workshop, is about our open centralized unit, decentralized unit. In the Open RAN world, the CU and DU are key components and key focus of future open source projects. So we call that OKUDU. We'll talk more about that throughout the day. But as part of all of our use of commercial technologies is, again, that idea of how do we secure them. So one of the things that we worked on over the past year across the US government, we coordinated within the USG, but with 9 other partner and allied nations to craft a joint vision on 6G. And we called it Secure and Open and Resilient by Design. So thinking about that, we look at the open source world and engaging with the experts in open source technology, like the Linux Foundation, to craft our approach to secure, open, and resilient by design networks. So key to this is one of the projects we've been funding called Security Enhanced RAN, or SE-RAN. Kind of like SE Linux, but making sure that we have a security enhanced RAN concept. This has been developed out of SRI and successfully transitioned some of the components that they've developed for securing the edge, for securing the RAN, into the Nefio project. So we actually have direct ties to engaging with the open source community and making sure that the funded efforts that we're pushing for enhanced security of our networks get integrated into the RAN and into these networks. We also have a significant effort in the Department of Defense to make sure all of our future network deployments are based on zero trust architectures. And this is a key to securing our future, securing our information, and deploying our network successfully and resiliently. So ensuring that we have ZTA technologies and ensuring that we are embedding those ZTA technologies in these future G networks is critical. And so for all of the open source concepts out there, we're trying to take advantage of them, trying to understand through the transparency of them, and by crafting them in ways that they're modular, that they work with these commercial solutions, that they work with industry, and incentivize innovation in industry is a key part of the vision of how we utilize open source technologies to create this secure, open, and resilient network. So I invite you all to join us for the 6G Innovation Day that we're going to host starting after this. There's going to be a significant number of US government agencies present today that you're going to hear from. A lot of partners that we built up that share this vision of creating this kind of resiliency for our future networks. And you're going to hear from their opportunities and funding efforts and research projects that they've been working towards with us to craft this future that we're looking towards. So going from 5G into 6G. We're in 2024, we're only about 4.5, 5 years into the deployment of 5G, and yeah, we're already talking about 6G. In fact, we're already too late talking about 6G. We're already thinking about 7G. 6G, though, is in a critical moment of its development for what it really means for the world. What is the differentiated concept within 6G to grow from 5G? We've been having these discussions for a while now. This is one of the defining years. Between this year and next year, I think we're really going to lock down what 6G means. I think you're going to see a lot of capabilities of openness. The Open RAN concept is really taking off and will be our future. I'm pushing for more of an open source implementation of that Open RAN so that we again can create that game changer, that disruptive technology. So when it's integrated and it's open and it provides a platform for research, innovation, and development of differentiated services, we can all benefit from that base. Speed up the innovation cycle, make sure that we are engaged in the different technology areas that are going to matter. I have spent 15 minutes on stage, and I'm finally going to do it. How do we utilize AI ML in our 6G networks? It's going to take a lot of data. It's going to take a lot of analysis. It's going to take a lot of trial and failure in order to understand how these things can benefit us within these networks. An open platform of innovation is going to be key to making that happen. So that's one of the big critical areas that we're interested in. I talked a lot about IS&C, Integrated Sensing and Communications. Again, we're going to need a lot of data. We're going to need a lot of innovation. We're going to need speed to understand how these systems can all operate and work together. Again, back to how do we make sure that there's an open platform for that innovation. And we're here, and we've been building this relationship for many years with the Linux Foundation in order to take advantage of not only their expertise in open source, but also their expertise in applying open source technologies to successful commercial and business practices. That's really important for us in the DoD. If we're going to take advantage of commercial solutions, we want to make sure we have the most robust commercial technologies available to us and engage with them early and often. And the dialogue that you can start within this open source community is key to that success. And so we're really happy to be here. You're going to hear some great talks from the National Telecommunications and Information Administration, NTIA, us from OUSD, R&E from the Pentagon. We have the National Science Foundation, key partner in all the research and development that happens in this country. We've been working with the National Institute for Standards and Technology, or NIST, as part of this to make sure, again, we have the right basis of measurement and understanding of security and of resilience. Department of Homeland Security, key feature, key partner in this work as well. So those are some of the people that you'll hear from today that are part of our growing coalition of U.S. government interests in making sure that we create this secure, open, and resilient networks of the future. So I invite you all to join us for this workshop for the rest of the day. Really excited to be here. And with that, I will finish up and thank you all for your attention.